Today's video will explain the composition relationship in a class design. Hello, I'm James Helfrich. When we work with class design, there are several different relations. There's composition, aggregation, association, nested class, and finally inheritance. This video will explain the composition form of class relation. Composition is probably the most useful type of class relation. So the question is, what is composition? Composition, composed of, comprised of, those are kind of synonyms. So that kind of gives us a clue. So composition is a special type of class relation where one class is an owned member variable in another class. To simplify discussion, we will call the containing class the host and the member variable of type attribute. For host to be comprised or composed of attribute, then host must have a member variable of type attribute. Additionally, the attribute must create and destroyed by the host. So for an example, I'm going to have a class called host, and notice I'm going to have a member variable or an attribute called A. The data type is attribute, which means I have to have another class called attribute, and there's going to be a horizontal line between them, means they're associated. But now this association is special because we have a member variable. And therefore, we're going to use the filled diamond, which is the composition diamond. And we really need to specify how many elements there are. In this case, there is one instance of attribute within the host class. Now, let's take a look at a trivial composition. Every time a class has a member variable, then composition is a possibility and, in fact, the most likely case. So let's say, for an example, in C++, I have a class called name. Then I'm going to make a class called name in my class diagram. I'm going to have three public methods, a constructor, a setter, and a display. Okay, these are all public. I'm also going to have a private, which is a string. So I'm going to say first is my variable name and of type string, which means I need to have another class called string, and there's going to be a relation between it, which is composition. Notice there's exactly one instance of string in my name class. I'm also going to have a middle initial, so the data type is a character, and then I'm going to have a string for a last name. So when I say string, now I'm going to have two strings, not one, so my numerosity is going to go from 1 to 2. Normally, we do not include built-in data types of classes from standard libraries in a class diagram. We only include classes which we author ourselves. Now, since a standard template library string we do not author, I'm usually going to omit that, and I'm not going to need composition to express it. Well, let's try something slightly more complex. I'm going to have my class called student, and a student is going to have three public methods, a constructor, a setter, and a display. Okay. I'm also going to have a private name. Now, notice name is not a built-in class. I defined it myself. So therefore, I'm going to have my name class from before. And since I'm going to create and destroy a name attribute when I create or destroy a student object, therefore, there's going to be an association. And that association is composition. And notice there's exactly one name for every student. I'm also going to have a GPA, and that GPA is a built-in data type of floating point number, so there's no need to include numerosity or composition for a built-in data type. Okay, let's get a little bit more complex here. So I'm going to have a course. A course is going to have a constructor, an add a student, and a display. So I'm going to have construct my add and display. I'm also going to have a private course prefix and a private course number, and those are built-in data types, string and an integer, so there's no need to have a class association. I'm also going to have the name of the instructor. So that instructor is going to be of type name, and I'm going to make a class called name, which I had before, and I'm going to relate to my composition, and notice there's exactly one name in this course. I'm also going to have a collection of students, an array of 20 students, in fact. So I'm going to bring my student, which I previously defined in here, and there's going to be one name for every student that's from before, but there's going to be exactly 20 students that are associated with my course. I'm also going to have a num students member variable as well. So notice how when my numerosity is different than 1, I really need to include how many there are. It's a best practice to always include your numerosity with your composition diamond. Okay, let's look at a slightly more complex example. I'm going to have a template class that contains a collection of elements. So in this case, I'm going to define the vector very similar to the standard template libraries vector. Notice this is a template class T, so therefore I'm going to say vector with that little T in the corner means the template class. And I'm going to have a couple methods: push back, square bracket operator, size, and clear. All right, these are all public, just as we expect. I'm also going to have a private member variable called num elements, and this is of type integer. Size t is an unsigned int, it's one of the many flavors of integer. I'm also going to have the num capacity, which will be another integer. And then I'm also going to have a collection of data. Now in C++, when I dynamically allocate an array, then I use the star, which means it's a pointer. But in reality, we know this can be a collection of them. So I'm going to use the cleanie star to indicate there is going to be many t's in my data. But t is going to be another class or a data type that I'm referencing from vector by composition. And how many are there going to be? Many. How many? Well, num elements, but it's going to vary at runtime. One thing to notice here, this t could be a built-in data type like an int or a float or a bool. It could be something from the standard template library like a string, or it could be a user-defined class. At this point, I don't know, so I'm just going to include it as a t. One more example to be even more complex still. I'm going to have a course, once again, just like before, and it's going to have my add student as well as my display, just like before. I'm going to have my course prefix and my course number as my built-in data types, just like before. I'll also have my name of my instructor, which means I'm going to have my name class related to course by composition, and numerosity is 1. This is exactly the same as my previous example. But I'm also going to have a vector of student. In other words, rather than a built-in array, I'm going to use the vector we used before. So now I'm going to say many students in my course, which means I'm going to have the vector class. And how many vectors are there going to be? Exactly 1. And each vector is going to have a collection of element, but that element is going to be a student. So therefore, the vector is going to have by composition many student. And that student, don't forget, is going to have exactly 1 name. So here we have a single class diagram that has 4 instances of composition. You can learn more about composition in the composition section of the Class Diagrams 2 chapter of the Software Design textbook.